Hello, my name is Fatma Erbash and today I will be presenting my parametric project, which is the Stade de Casablanca. So to start off with the roof form generation, I started by first creating a polygon that was segmented based on the amount of sides I wanted, and then I got the control points of the polygons and inserted it into two cull patterns. And based off of these cull patterns, I entered it into two scale batteries, in which these batteries were later connected to a move and a weave component. And the move and weave component helped me create the tapering of the top star shape. From that, I lofted the inner edge with the outer edge of the shape, and then I entered it into a bank battery, in which it gave me the two different lines that I wanted. And from these lines, I was able to further divide the inner curve and create a polyline based off of that, in which the polyline consisted of points that moved upwards and downwards. And from the polyline, I was further able to enhance the shape by creating a loft, and this loft actually constructed the segmented shape of the top roof. And then the final form came from triangulating the simple mesh and having it all joined together and moved up. After constructing the top star form, I then began to generate the bottom star form by first reusing the same polygon we originally had, but further dividing it and connecting this division into list items. The list item batteries were used to help me find the individual points and connect them into move batteries based off of the form that I wanted to generate. So some of them were connected to move batteries and were moved using vectors. And then these points were connected into these lines, and these lines helped me generate the overall form. After generating the form using these lines, I then connected the lines into loft batteries to construct the surfaces that I wanted. Once all the surfaces have been lofted, I connected some of them to flip batteries in order to have the face normals be unified. And then I later connected all these lofts into two batteries, which one of them is the merge battery and the other is the V-wrap battery. After connecting all the lofts to the V-wrap battery, I created a simple mesh, and then I did a split quads in which I divided it into two different quads at two different levels. And I took the mesh of that and input it into a mesh vertices battery. And based off of these vertices, I was able to use the clothed points for the load and the naked points for the anchor battery. And these two outputs were actually used into the entwine, which later leads into the multi-solver. For the vector of the amplitude, I unified all the face normals and used the normals as the vector in order to have all the mesh faces rise the same way when using the bouncy solver. In order to alter my bouncy solver to get the results that I want, I had to change the amplitude in the load, and I did this by using the number sliders here, and I also input a smooth component to get the results that I wanted, in which the results are going to lead into bubbling these triangle panels into a curve. To show the results of my physics simulation, I scaled it up and inserted a color swatch into white to fully show the effect of the bubbling. As for my kangaroo physics simulation, this is the bubbling effect that was previously mentioned. For the interior of the building, I wanted to generate a truss the same way it could be generated using a physics simulation, but without actually using the kangaroo bouncy solver. And I was able to do this by using a simple mesh and a stream gate battery. Once the stream gate battery toggle is turned to true, this is how you can see that the truss has been generated. And this is done by using a triangulate panel and refining it based off of the amount of openings I wanted. The same method is applied to the bottom portion of the building, in which you can also control the thickness of the truss itself by using the weaver braid thicken that's connected to the weaver braid frame. As for the ground condition of the building, what I did is I started off with a polygon, and this polygon is actually projected onto the surface, seeing as it's the same polygon that's used to create the overall form of the building. And once projected onto the V-wrap, it constructs the form. So this is the V-wrap, in which it's an oval. And then after that, I was able to create multiple geometries in which I took the same geometry and scaled it based off of the results I wanted and rotated it. For the final part of the interior of the stadium, I was able to generate the soccer field and the seating using a plugin called Pool Builder. And as you can see here, it generates the overall form of the field. And then I can also generate the seating and the stands, which are here. And everything about this can be altered using these number sliders placed in the ball section. This was my attempt to recreate the Grande Stade Casablanca. Thank you.